Okay, welcome. So we are now on to coding. We're on the exciting part of the class. So first lab, pretty tough. First time you guys have ever seen this stuff, don't worry about it. Do not get discouraged. Just keep on trying, okay? I'm going to be here to help you through it, and the first thing that I'm going to help you out with is problem 3. I'm not going to tell you guys the answers to the whole lab, of course, but since a lot of you guys already did this inside the lab, I feel like it would be good to do it in front of you, just so you have a full understanding of what you did, if anything was unclear. So this problem was told you to set bits, clear bits, and then invert a bit. All right, so this problem is, we're going to take it step by step. And the first step is setting the bits 0, 4, and 12 to 1. So remember, in the in-class assignment that you did recently, in order to set a bit, you have to use the OR command, which is ORR in assembly. So the first thing you need is OR, but the next thing you need is a bit mask. So the way that I like to do these problems to make it a lot faster for me and easy for me to visualize is just start with a bunch of blank zeros down here. That way you have them to work with whenever you have to create a bit mask of some sort. So remember, when you're using OR, whenever you want to set a bit, in that position you just put a 1 there. For the bits that you don't want changed, you put a 0 there. So in this case, the 0th bit, or the rightmost bit, needs to be set, so we're going to make sure we put a 1 there. The 4th bit also needs to be set, so we're going to count up to 4, so we're at 0, 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have to go ahead and translate this to hexadecimal before we can use it. So it'll be 0x, a bunch of zeros, I'm not going to include those, and then 1, 0, 1, 1. Alright, so we're looking pretty good so far, so let's go ahead and see what happens if we try this. It's not going to work just yet, and you're going to see why. It says that this value right here is too big. So there's actually 2 ways around it. I'm going to show you probably the more inefficient way, but the easiest to follow. So the easiest thing to do in this situation is to move it into a register first. And since it's too big, and we only want to move something into the lower half, I'm going to use move W. Because remember, move W moves a bunch of zeros into the upper half, and then the lower half, the value that you want. So we're going to use R0 just as a placeholder, and then we're going to move in our bit mask. And then we're going to do OR. The result is going to be stored in R6, and the 2 things that you're ORing together are R6 and R0. Alright, so this sets bits 0, 4, and 12. Alright, so that's the first part. The next thing we need to do is we need to clear our bits. In order to do this, we're going to use bit clear. Now the beauty of bit clear, unlike AND, is it allows us to use the same exact logic as we just did. The bit that you want changed, put a 1 in there. The bits that you do not want changed, you put a 0 there. So let's go ahead and rework our bit mask down here. So resetting these back to blank zeros so we have a template to work with. It said that bits 8 and 31 needed to be altered. So this is bit 4, this is bit 8, so that needs to be altered. And then bit 31, which is all the way over to the left, also needs to be altered. Okay, so the binary mask for this would be 0x, 8, 4 zeros, and then that right there. So just looking at this right here, you are not going to be able to use that as an immediate value because it is too big. So in this case, since you're working with the whole entire, length of the register, you're going to use move W and move T. So again, I'm going to use register 0. Now for move W, we're going to move in our lower half, which is going to be 0x, 0, 1, 0, 0. And then into the top half, I would like this value. So once we have our bit mask all loaded up, we are going to use bit clear against R6 and R0. Now the last thing that we need to do is we need to invert bit 5. So again, reworking this bit mask right here, These are now become zeros, and the bit that we want inverted is 0, 1, 2, 3, 4, 5. This bit right here. Which if we rework this into a hexadecimal mask, we're going to have 0x, a bunch of zeros, and then 2, 0, which you can in fact use as an immediate value. So Eeyore the donkey, and this time we're going to go straight from 0x to 0. So let's go ahead and build this code. Just a little warning, this is acting really buggy tonight. I'm not sure what's going on, so it has a tendency to shut down suddenly on me, so just be patient if it does. Okay, I got lucky so far. So in the parentheses right here, when all of these run, this is what we should have in R6. So let's go ahead and step through it. So we've got our original value in there. And then in R0, we place our bit mask in order to set the bits. And then we do OR. And then we move in our new bit mask to clear the bits. And then we do a bit clear. Then we do XOR. And we do, in fact, have the result that we desired. So that's how you work with bit masks and logical commands, setting, inverting, and clearing bits in ARM assembly. Like I said, a lot of you guys already got this really good in lab, but this was just meant to supplement what you already know. Hope you enjoyed it, hope this was helpful, and stay tuned for the next video.